cause and effect feel unquestionable. One event happens, then another follows. Push something, it moves. Heat something, it warms. The world appears to unfold as a chain of causes producing predictable results. This structure feels so basic that we rarely question it. Without cause and effect, reality would seem impossible to navigate. Physics quietly disrupts this certainty. In classical physics, causality is clean and reliable. Events occur in a clear order. Effects follow causes. The future is determined by the past, but as physics moved beyond everyday scales, this simplicity began to break. At high speeds, near massive objects, and especially at quantum scales, cause and effect stop behaving as expected. Relativity already complicates causality. When time is not universal, the order of events is no longer absolute. Two observers can disagree on which event happened first, and neither is wrong. Causality becomes dependent on perspective. What seems like a cause from one frame may appear as an effect from another. Quantum physics goes further. At microscopic scales, events do not always have clear causes. Particles appear and disappear. Outcomes occur without a single identifiable trigger. Processes are governed by probability, not certainty. The universe does not always provide a clear reason for why one event happened instead of another. This does not mean physics becomes chaotic. It means causality becomes statistical. The laws do not dictate exact outcomes, they constrain possibilities. Reality follows rules, but those rules do not specify what must happen, only what can happen. In some quantum experiments, correlations appear without a clear causal chain. Two distant events behave as if they are linked, even when no signal could have traveled between them in time. These correlations do not transmit information faster than light, but they challenge the idea that cause must travel locally through space and time. The universe allows relationships that are not mediated in the way classical intuition expects. This forces a deeper question: is causality fundamental, or is it emergent? At large scales, causality feels solid because probabilities narrow. Many microscopic uncertainties average out into stable patterns. Effects reliably follow causes because alternatives cancel each other. What appears deterministic may be the result of overwhelming likelihood, not necessity. In this view, cause and effect are not basic features of reality. They are useful approximations that work where uncertainty is suppressed. Beneath them lies a structure where events are linked, but not ordered in the way we imagine. Time and causality are deeply intertwined. If time is not fundamental, then causality cannot be either. The idea of one thing producing another assumes a flow of time. Remove the flow, and the notion of cause begins to dissolve. Some interpretations of physics suggest that the universe may be globally consistent rather than locally causal. Instead of causes producing effects step by step, reality may exist as a self-consistent structure where events fit together across time. As a whole, the universe does not evolve forward. It is arranged. This idea feels disturbing because it threatens agency. If events are not caused in the usual sense, what role does choice play? If the future is constrained by global consistency, where does freedom exist? Physics does not resolve this tension, it exposes it. What becomes clear is that causality, like time, may be a perspective-dependent tool rather than a universal law. It helps us navigate experience, but it may not describe reality at its deepest level. Human experience mirrors this instability. Decisions often appear rational after the fact. We construct causes for choices that emerge from complex, unconscious processes. The sense of "I chose" Because of this may be a narrative imposed on events that did not follow a simple chain. Memory reinforces causality. We remember sequences and infer necessity. But remembering an order does not mean that order was required. It only means it occurred. Physics and psychology converge here. Both suggest that causality is partly constructed. It is a way of organizing experience, not necessarily a window into the structure of existence. This does not render the world meaningless. It makes it subtler. Events are still connected. Reality is not random, but connection does not require linear cause and effect. Relationships can exist without one thing producing another in sequence. Understanding this softens the demand for control. If not everything is caused in the way we expect, then not everything needs to be managed. Prediction becomes less important than attention. Participation replaces domination. Physics does not remove causality from daily life. It removes it from the foundation of reality. Cause and effect remain useful, but they are no longer ultimate. At the deepest level, reality may not be a chain, it may be a structure. Events do not push the universe forward, they fit within it. When this is seen, experience becomes less rigid. The pressure to trace every outcome back to a reason relaxes. Existence feels less mechanical, more open. The universe is no longer a machine producing results, but a system maintaining coherence. Physics does not tell us how to live without causes. It tells us that causality may not be as absolute as we assume, and that realization alone changes how reality is met. Still, within